Okay, now our question says is that derive an income consumption curve for the following utility functions. Okay, u equals to xy. Now remember this, that income consumption curve is the locus of all equilibrium points, okay, when income changes. Okay, now remember this, that income consumption curve is also drawn in x1 x2 space. I'll just draw this for you. This is a budget line, this is an indifference curve, this is an equilibrium. Another budget line because income changes, another indifference curve, this is an equilibrium, and this, sorry, your this becomes your income consumption curve. And remember this, that this is in x1 x2 space, this is not in prices space. Okay, so prices are held constant out here. So again, this point has to be noted, that prices are held constant. Okay, so prices are held constant out here. So you have u equals to xy. Okay, from your first order conditions, okay, that is, if you set up a Lagrange, you'll be getting xy plus lambda m minus p1 x1 minus p2 x2. Okay, we'll just derivate this, del L by del x is equal to y minus lambda p1 equals to 0, del L by del y equals to x minus lambda p2 equals to 0, and del L by del lambda equals to m minus p1 x1 minus p2 x2 equals to 0. So you divide 1 by 2, you will be getting y upon x is equal to p1 by p2. This is your income consumption curve in case of a Cobb-Douglas utility function for a given level of prices. Okay, for a given level of prices. Fine. So this is your income consumption curve for a given level of prices. Now in the second question, that is your u equals to min of x1 x2. Okay, from your first order conditions, I mean, of course you can't differentiate it. Okay, this is not a differentiable function, so you don't use Lagrange, but you know this, that x1 is equal to x2 is the case, and this is your income consumption curve in case of perfect complements for a given level of prices, for a given level of prices. Okay, so this becomes your income consumption curve in case of perfect complements for a given level of prices.